So where does it belong? The alternative hypothesis is the one that does not have an equal to. Now, I don't care which subscripts you use, but if you use one that isn't clear, like some kids just like to use P1 and P2, which is absolutely fine, especially when you see how you're going to put these in your calculator. But if you do that, you need to do P1 equals softball. You need to communicate it to me somehow which one is your P1 versus your P2, okay? So this could have also said P1 is greater than P2. I'm fine with either, okay? All right, if my alternative hypothesis is strictly less than, my null hypothesis is going to be the opposite of that, which is less than or equal to. Everybody good so far? All right. The next thing I'm going to have us do to test these hypotheses, what we need to do is figure out what are our critical values. And rejection regions. A reminder, what I would expect to see to find those things. A picture centered at 0, because we're describing z-statistics here. And z-statistics always have a mean of 0 and a standard deviation of 1. Then I'm going to shade my rejection region. So as we shade our rejection region, there are 2 things we need to think through, okay? Where is my rejection region and how big is my rejection region? So let's start with the where, right, left, or both. Because this part is identical to what we did in the previous 2 units. We are the sign of our alternative hypothesis. The sign of our alternative is telling us where to shade, which is pointing to the right. So we're going to shade to the right. And how much am I going to shade? 0.05 alpha. At this point, because like I said, I have graded your tests. I'm going to give you guys 1 minute to write down notes to yourself as to how you decide each of these things. Because a lot of us put our hypotheses wrong and put the equal to in our hypotheses, and then we shaded the wrong direction. So make sure you are writing down for yourself, not just what I write down, but what you need to study. Because that's what note-taking is. It's not just about copying and aping what the teacher does. Because in college, you're not going to be able to write it all down, because it's not like this. Teachers just talk the whole time, and you have to parse out what is the important stuff. Okay? Take the time to write down what you need to look at for yourself later to help you make decisions on when you're going to have to do this on your own. Then we can find our critical value. How do I find my critical value in this case? Z-test will give me my test statistic. It will not give me my critical value. Inverse norm is how I would have to find my critical value in this case. Z-test tells you what the sample suggests. It doesn't tell you where the boundary is. What are we getting?
1.645.
We should be getting 1.645. Okay. The next thing we need to find is our test statistic and our p-value. We're going to get our test statistic and p-value from the shortcut menu in your calculator. Now, before when we were doing a test for a proportion, we were supposed to be doing the one prop z-test, because that's the one that's for proportions. How many proportions do I have in my hypotheses? I have 2 proportions in my hypotheses, so guess which one I should pick? 2 prop z-test. Now, you'll notice now you have x1, n1, x2, n2. What matters, the order that you put these in matters, okay? So you want whichever one, this sounds stupid, but this is a problem every single year, okay? The one you write first, in this case, that would be softball, yes? Okay, then I need to give the sample proportion for softball. So for X, I'm going to do 15. For N, I'm going to do 40. In terms of understanding where that came from, that first line tells me that the p hat for softballs was 15 out of 40. If you try to put a decimal in, it's going to tell you domain error because your calculator knows that X and N should be whole numbers. Okay? Then we also have that the p hat for weightlifting was 8 out of 30. You'll notice it's not asking you for a value from your null hypothesis because there is no value from your null hypothesis. It knows greater than versus less than. Is everybody okay? All right, my z statistic is 0.95, and my p-value is 0.170. Now, okay, so my z statistic, 0.955, puts my sample right about here. How would you describe that? Our goal is trying to decide which of our hypotheses is true, yes? So this area, remember we call that area the rejection region. So when we get our sample value, we have to decide, is it in the rejection region or not? So, you guys, is it in the rejection region or not? No. Okay, so I would describe that as not in the rejection region. Likewise, my p-value, we'll come to the same conclusion, okay? So to do our p-value, we compare it to alpha. 0.17 is bigger than 0.05, okay? And we reject when our p-value is less than alpha. So both of these things mean I fail to reject. And when we fail to reject, What are we not rejecting?
Null hypothesis.
The null hypothesis. Okay? Now, on tests, some of you guys put my values in the rejection region, so I fail to reject. You guys catch my drift? Okay? There's a reason I'm not just flying through this. This is something that you guys definitely struggled with on the test. However, your scores were a perfect bell curve, which was, interesting to me. The scores on this test were approximately normal. All right. So what's my conclusion? If I am not rejecting this hypothesis, yeah?
With a 95% confidence.
With 5% with a 5% level of significance, we have support that says softball players use less or equal have lower proportion or equal to proportion use of steroids. Okay? Questions? I'm going to say steroid use is not more prevalent. I like to use the verbiage from the question whenever possible. Any questions on this? Okay. Next, when we do a 90% confidence interval, okay? When we run two prop Z intervals, okay? What they do, instead of saying form, is they estimate PS, the value of the differences, okay? So remember, confidence intervals create an estimate. They give us hey, we think the population value is somewhere in between these two numbers. Okay, that's what a confidence interval does. So now what that actual true value we're trying to estimate is what is the difference between the two groups, okay? So when I look at my null hypothesis, okay, my null hypothesis is going to say that PS minus PW is less than or equal to 0. Because if I rewrote this hypothesis into a subtraction problem and subtract PW from both sides, I would end up with a 0 on the right. Okay? So if my two groups are the same, their difference would be 0. So when we talk about comparing confidence intervals to tests making that same conclusion, what we're looking for is 0 in the interval or not. Because if 0 is in the interval, it's reasonable to say there is no difference between the two groups. Is everybody good? Okay? So now, to calculate said interval, you're going to hit stat, you're going to hit arrow over to tests. And if we scroll down, so we have the 2 prop Z test and we have 2 prop Z int, option B. Now, real quick, when we did confidence intervals by hand, the picture to find that critical value looked like this. You guys, what is the area in each tail here for my confidence? If remember, the confidence level is my middle 90 or my middle confidence level percent, right? In this case, this is 0.05. This is 0.05. Based off of this picture, what is this value? Do you guys see on the right side, this is the exact same picture, okay? And then the opposite side. So as long as my picture and these match, okay, as long as those critical values match, the test and the interval will come to the same conclusion, okay? So should I expect 0 to be in this interval or not? Well, did I reject? Did my test reject? No. Which means this equal to could be true. I would expect 0 to be in this interval because I didn't reject. If 0 wasn't in the interval, like the entire interval is negative, or the entire interval is positive, that would suggest, if the entire interval is positive, that would suggest the alternative hypothesis is the true hypothesis. Is everybody good? Are we seeing that? Because the alternative hypothesis could also be written that PS minus PW is greater than 0. So if my entire interval is greater than 0, that's a good idea that if the differences are all positive, then the bigger one is bigger. Or the first one's the bigger one, yeah? Okay? Now, when I do this, I am not surprised to see my interval having both positive and negative values. We'll talk about this more tomorrow. All right, so in a recent study, 200 randomly selected adults were asked if the local radio stations offer enough variety. 113 said yes. All right, so as I'm going through these types of problems, one of the things I want to start thinking through is, again, we're comparing two distinct populations. I can read from that first question, one of my populations is adults, and the p-hat for the adults was 113 out of 200. Okay. $175 randomly selected teens were asked the same question, and 83 said yes. So now we're at p-hat teens equals 83 out of 175. Okay. All right. So when we are doing this question, so in this particular case, we're asked to do a 90% confidence interval. Okay? In this 90% confidence interval, what we want to do is estimate what is the difference in the adults minus teens. Okay? So the adults are going to be our population 1, the teens are going to be our population 2, because I was told the direction of this. Okay? Now, again, there were some issues that popped up on the last test that I want to make sure we're all on the same page, so I'm going to go into a little bit more depth than what this question is actually asking to reinforce some of those things from Unit 7 and 8 that didn't pop up that as good that we are good conceptually from the test, okay? So 90% confidence interval. If I'm drawing a picture for a 90% confidence interval, anything for proportions means my sampling distribution will be a z distribution automatically for proportions, okay? And 90% puts me at 0.9 in the middle. If I have 90% in the middle, what is the combined percentage of my two tails? 0.1, because it's the 100% minus that 90%. Okay? So that makes this tail 0.05 and this tail 0.05, because combined they have to add to that 10%. Now, if I needed, a lot of folks on the test stopped here and didn't give me the critical values. Those critical values are really important. What do I do in the calculator to find those critical values? In this one, I would do inverse norm, because it's anything that's z is the normal distribution with a mean of 0 and a standard deviation of 1. And we should get positive and negative 1.645. If you are not getting those in your calculator, you should tell me now so we can figure out where the misunderstanding of what you're typing in is. A lot of you guys don't follow along in your calculators. You're just writing it down, and then you say, how do I do this in the calculator when it's time for you to do the test? Do this in your calculator now and make sure you know how to do this. Because some people were putting the wrong areas in, and then it caused some problems. Do we have any questions as to where this is coming from? All right, next, we actually have to calculate the interval. Y'all, the phrase interval means you should have two numbers. Interval means between two numbers, yes? Okay? Now, in our calculator, to find said interval, we're going to choose the 2-prop z int. You're going to have to scroll to get to it. Because this one specifically said to do the adults minus the teens, we need to put the fraction for the adults in. For the 1, for x1 and n1, and the fraction for the teens in for x2, n2. We're doing it, it's 90% again. Everybody good? Okay. Now, if that's the case, I want to know what is our point estimate and what is our margin of error. Now, the point estimate is the exact midpoint of our interval. Because remember, what do? We take our point estimate and we add the margin of error and then we subtract the margin of error. Right? Okay? So our estimate is our best guess. So it's the midpoint. So to find my point estimate, I can do this plus this divided by 2. Is everybody with me? Because that would give me the midpoint between these two numbers. Now, you guys, does this estimate make sense? What are we trying to estimate again? The difference between our two populations, yeah? So, what is the difference between my two sample values? It's the exact same point estimate. Okay, our best guess at the difference between adults versus teens as to whether or not they think radio stations provide enough variety is the difference between my two samples. Now, our reasoning process says, what do we know about both of our two samples? They're not perfect. We could take two different samples tomorrow and get totally different results. Okay, so our samples aren't perfect, but they are. But so the question is, so why are we seeing that, right? Why are we, that's our best estimate for what it is, but because it could be tomorrow I take a sample that's 56.0% and 47.0%, and then for that one, my difference is 0.09%. Like every set of samples, I could get different answers, okay? But overall, they're going to be close to this, assuming our samples are reasonable samples, okay? But because that difference changes depending on my samples, we need a little bit of wiggle room, hence we add a margin of error. How could I figure out what was my margin of error? Well, I took this 0.091, my estimator, plus or minus my margin of error, and that's what gave me the interval. I like to do the plus one because it's easier for me to imagine everything. So 0.091 plus my margin of error gave me the 0.175.
For that, you can get a different answer if you use the minus or the positive.
That's why supporting work is a really good idea.
Okay.
But I'm usually, like, it'll be real close, right?
Right, it's only off by 0.001, but
Yeah, like, oh, that's fine. I'm not worried about that. Okay. Everybody good? All right. So, my interpretation with 90% confidence, we can say the difference in population proportions, adults minus teens, and again, I'm pointing out, y'all, I'm stealing all the verbiage directly from the question. Is between 0.006 and 0.175. Everybody good? All right. Now, based on the interval, can we say for sure there is a difference between the two populations? So to think this through, y'all, what would no difference mean in terms of if there's no difference between the two groups? The difference would be 0. Yeah? So if I'm trying to decide, is there a difference or not, this interval is describing the possible differences. Based off of this interval, can we say that the possible difference could be 0? No, because
0 doesn't lie with it.
0 is not in the interval. Is everybody with me? Now, if instead I asked you to answer this question, can we say there is a difference? My null hypothesis would be that PA is equal to PT, and my alternative would be that there is a difference, right? Is everybody with me? Okay, and if I were to sketch my sampling distribution, if I asked you for, let's say, I don't know, alpha equals 10%, which is the same thing as a confidence interval for a 90% confidence interval if we're two-sided, okay? Are you guys with me that this would be the exact same picture at alpha equals 10%, right? So the picture I draw for a confidence interval, especially for two-sided, is almost identical to the picture I draw for a test, okay? So what would we expect if I asked you to do the z statistic and the p-value? Okay, I would expect that my z statistic is somewhere in the rejection regions, right? Because my interval suggests there is, in fact, a difference, because 0 is not in the interval. So my interval is suggesting the alternative hypothesis is true, which means I should reject the null hypothesis. So when we're going to run this test, and I just want to show you guys, the z statistic will be, in fact, be in the rejection region, and the p-value will be smaller than 10%. Is everybody good? Because they're making the same decision. There's a connection between all of these things. So let's go in stat, and this time we're going to pick the 2-prop z test instead of the 2-prop z int. You'll notice the fractions and stuff are still there. Notice I'm changing my alternative hypothesis to not equal to. Yesterday it was one-sided. Today it's two-sided. So we got to make sure we're changing that alternative hypothesis to go with. And again, that 1.75 right here is inside the rejection region, and my p-value is in fact less than alpha. Both of those would make me say at 10% significance, PA is not equal to PT, because I've rejected that null hypothesis. The alternative is the hypothesis I have support for. Okay? Are we seeing the connection here? They're the same thing. We're just, one is making an estimate, one's testing, are the two of them the same or not? Okay? Now, if this had been greater than or less than, we have a different story here, and we'll talk about that a little bit more with the proportions later on this week, okay? Or with means. Okay, so I'm done with notes for today.